So I made a video in the channel. You can check it out. It's a proof on essentially what is the first derivative test. It's a proof on why the critical point is either a max or a min, and really check that out. It'll give you some insight as to how you can really come up with the idea of a first derivative test. But now we're going to actually see what we're going to, what problems are going to look like on the AP Calculus AB and BC exam, because this is a pretty big unit and you really have to understand the properties of derivatives and what they really tell us about our good old function f. So let's say you have some function f, and let's just say it's continuous for all this interval, and it's kind of going like this. Let's say it's something like that. Okay, now obviously we have a local maximum right over here, so this is a local maximum. We have a sort of a local minimum right here. We have a local min right here. And let's just pretend that if this was drawn right, there's a max there. Now, how would we actually figure out where these maximums are? For what x values do these maximums exist? That's the question we're trying to ask. So, essentially, what is this c? If this was c, then you want to know what that constant is. And that's what we're going to really be looking at today with this first derivative test, which is exactly what is going to output this constant c. So let's say, once again, we have some function, and it's just a good old, let's actually do a good old parabola. Draw a little bit better. Okay, so we have the function f of x is equal to x squared, okay? So, of course, there's an absolute minimum here. Now, just keep that in mind for a second here. It doesn't matter that it's absolute minimum here. In this case, we'll talk about that in a different video on how to find the absolute minimum. But, just, obviously this is 0, 0. This point right here is 0, 0. But let's say you didn't know. For some reason, you didn't know what that point was. How would you find that point where there's a maximum, or a minimum, or some extrema? Now, I want to see, let's take a look at what the graph of f prime of x looks like for our function. So we notice that the function is decreasing here. And if f is decreasing, then f prime is less than 0. Okay, so really keep that in mind. So that means that for some values, it's decreasing all the way to the left of 0. So let's say f prime of x is less than 0 on the interval from -infinity to 0. Okay, so keep this in mind. Well, that means that then it's going to look something like this. Now, keep in mind that look how the values here, that they're decreasing less and less. The slope of the tangent here is less than the slope of, is much smaller than the slope of the tangent here. This is like -5, this is like -2, right? And so what's happening here is we're getting closer and closer to being positive. So it's kind of, it's decreasing, but it's decreasing at a decreasing rate. So our function curve is actually going to look like this for f prime to the left, because it has to go closer and closer to 0. And just based off of that, you might say, okay, well, if on the right side, so f prime of x is greater than 0 on the interval from 0 to infinity. And okay, well, that's just going to be another line. So the graph of f prime of x is just a line here. And of course, you already know at this point that the derivative of f of x equals x squared. Well, the derivative with respect to x is just 2x, right? So of course this is our line. Now take a look at where the point 0 here matches on the derivative curve. Notice that the point right here is also hitting 0. Now that isn't a coincidence that it's 0 at 0. It's literally because f prime is equal to 0 at the minimum. Okay, so we're at the minimum, and therefore we have f prime of x equals 0. So here's what you need to do. Now that we kind of see how the derivative is related to finding the points of extrema, I'm going to tell you now the formulas that you're really going to know. Not really formulas, but things you're going to need to memorize. Okay, so there's a series of steps you need to do. The first step is to find critical values or critical numbers. And why? Because here we notice that it's where the derivative is equal to 0 is where the minimum occurred. So we need to set f prime of x equal to 0, solve for x. Then determine the type of extrema. So after you find that the critical number, what's going to happen is that you're either going to, it's going to be very obvious that if it's a max or a min, because in this case it was a min, but there are cases where this could actually be a max. For example, if it was like, if the derivative was like this is a derivative for the function f of x equals negative x squared. And in this case, or sorry, I think it's just negative x squared, like that. And for that function, we know that there's a maximum at 0, not a minimum. So we need to determine the type of extrema, and we're going to use the sign chart. Okay? And of course, this sign chart, I have an entire video on it, so you can really go through that. But check it out and really understand the sign chart method. If you have your own method, by all means go for it. Okay, so let's do an example. Let's say we have f of x equals x cubed minus x squared plus x as our function. Now actually let's go even easier. Let's just do this. So find all extrema. X coordinates. So here's the problem. So first step, of course, we need to find the critical numbers. So find f prime of x, which is just going to be 3x squared minus 2x. Basic power rule right there. We're going to set this equal to 0. So 3x squared minus 2x is equal to 0. X we can factor out here into this. And so x is going to be 0 or 2/3. Okay, so these are our two critical numbers right here. So there you have it. So these are your critical numbers right here. Okay. Now we need to do a sign chart. So step 2 is we need to do a sign chart. So we're going to label our chart here. Top is f prime, bottom is x. Put your critical numbers in increasing order, so 0 and 2/3. Now let's analyze the critical point for 0. Where did that critical number come from? Well, it came from the x part right here. Okay, so I'll do this part in red. Now the function x to the left of 0 is just negative. It's below the x-axis. The function actually just looks like this. It's negative below the x-axis to the left of 0, and it's positive. So we're going to denote the negative by dotted lines. It hits 0, so it's a filled in circle. Then it's just going to be positive the entire time. Okay. Now let's do the other part. So we did the sign chart for for the critical value 0. So now we're going to analyze this blue function. to the left of 2/3, it's also going to be negative. It's going to hit that point, and it's going to be positive the rest of the way through. Okay, just to see what this looks like. So it starts here, and of course we have the slope of 3. So 1, 2, 3, 1, and 1, 2. So about right here is somewhere where the critical value exists. Okay, I drew that graph entirely wrong. I apologize. It's actually -2. Starts here. 1, 2, 3, 1. So right here, this is the point of 2/3, and we see that to the left of that point, the function is below the x-axis, so it's negative, and it makes sense. Okay, now remember that these are terms that are multiplied together, so we're going to do the same on the sign chart. So we have a negative times a negative, that's a positive here, positive times a negative, that's a negative, pause, right? So in this case, now of course that was very slow because I was walking you through the steps for you. You can do that on your own much faster when you get the hang of it. Okay, so we know that x, because f prime of x is positive on the intervals from -infinity to 0, and of course 2/3 to infinity, and f prime of x is negative on the intervals of 0 to 2/3. The AP doesn't care if you leave it open parentheses or close parentheses, because there is a huge debate on notation. And so all our extrema are going to be where these critical points are. Now, the reason I labeled this out is because, okay, well, we know there's extrema there, but we want to see if they're maximums or minimums. So x equals 0 is that a maximum or a minimum? Well, if you guess maximum, you are correct. And x equals 2/3 is a minimum. This is your answer. Why? Well, notice here that the sign chart, we're changing, f prime changes from positive to negative at this point. It's positive, then it's negative. Well, think about what that means. It's increasing, then it's decreasing. So you have a function, imagine it's increasing, hits 0, then it's decreasing. That's a maximum. In this case, for this 2/3 critical point, well, we have negative to positive. So it's decreasing, then it's going back up to increasing. So we have a minimum here. Okay? So positive like that, negative pause like that. Okay? So rule of thumb, if f prime changes from pause to neg, then it's a maximum. And based off that, you can figure out the other one. Now, on the AP, you would justify your answer by saying there exists a maximum at x equals 0 since f prime of x changes from pause to neg. Okay, so a really simple explanation there. And there you have it, guys. That's all you're going to need to know about the first. So this all right here is called the first derivative test. So all of this right here. First derivative test. Okay, so obviously make this a little bit nicer to read. There you have it. So this is all the first derivative test here, right? So step 1, remember, you're going to find the derivative, and you're going to set it equal to 0 and find your critical values. And the second step is you're going to do a sign chart, and based on that, find the intervals where f is increasing, decreasing, and determine based off of that if it's a mix, sorry, not a mix, a max or a min. Okay, so there you guys have it. Have a great rest of your day, and good luck on your AP Calc exam.